AI agents are becoming indispensable in organizations, yet traditional governance strategies often fall short. In a world where 78% of companies use generative AI, an effective governance framework is crucial to prevent failures and maintain trust. Today, we'll explore how innovative governance frameworks propose to close the capability identity gap, offer traceability, and why dynamic solutions are necessary. The rapid rise of AI agents in businesses has exposed critical gaps in traditional governance strategies, putting organizational effectiveness at risk. As organizations increasingly deploy AI agents to boost productivity, many find themselves without the governance frameworks necessary to ensure responsible usage. McKinsey's report highlights a disconcerting fact. Only 23% of companies have effectively scaled AI agents, yet over 70% lack responsible use policies. A significant development in this field is the introduction of a governance framework by Zhou. This framework aims to restrict AI agents to operate within authorized capabilities while maintaining traceability, essentially preventing unauthorized actions by agents. Key solutions include capability-bound agent certificates. These extend X509v3 certificates with a manifest hash of the agent's skills, ensuring agents only perform tasks they're authorized for. Reproducibility commitment methods. This leverages large language model LLM inference to verify actions post-execution, enhancing transparency. Verifiable interaction ledger provides signed records for multi-agent collaborations, allowing forensic reconstruction when needed. The performance of Zhou's framework shows promise, with certificate verification times as low as 97 microseconds and a governance overhead of only 0.62 milliseconds per tool call. These metrics indicate the potential for minimal impact on system performance, while an F1 score of 0.990 in single provider deployments speaks to its efficacy in classification tasks. However, there are trade-offs and limitations. The scalability of these mechanisms needs thorough validation. Existing frameworks may fail to adapt to the dynamic evolution of AI capabilities, and reliance on manual oversight can strain resources. Compliance with ever-evolving AI regulations remains a significant challenge. For those interested in exploring practical implementations, Zhou's paper on dynamic governance models for AI agents is a must-read. Additionally, integrating cryptographic binding into current AI systems could enhance an organization's governance capabilities. Teams should also consider training programs on responsible AI use to mitigate risks. The takeaway here is clear. Without robust governance, AI agents can become liabilities rather than assets. Embrace dynamic frameworks to manage the complexity and evolution of AI systems effectively. Recent advancements in large language models, LLMs, have led to the development of innovative frameworks that refine the ability of these models to assess output uncertainty and calculate confidence scores. Noteworthy examples include the Say-Self and Aspire frameworks, which have considerably advanced the transparency and reliability of AI systems essential for real-world applications. Say-Self framework. Introduced in May 2024, Say-Self employs reinforcement learning, utilizing a specially designed reward function to train LLMs to produce calibrated confidence estimates. This method not only improves the model's ability to gauge the certainty of its responses, but also encourages the generation of self-reflective rationales. This process mirrors a student's self-assessment when verifying answers, ensuring errors are caught and corrected. Aspire framework. Released in January 2024, Aspire focuses on enhancing the selectivity of predictions by enabling LLMs to output confidence scores alongside their responses. The introduction of selective prediction mechanisms allows models to express certainty levels, akin to a human expressing a degree of confidence in their answer. When applied to question-answering datasets like Coque, Aspire outperforms state-of-the-art methods, a testament to its advanced capabilities. Technical mechanics. A crucial aspect of these frameworks is the integration of normalized confidence scores, which are based on output anchor token probabilities. These scores play a pivotal role in detecting errors, providing a quantitative measure of output reliability. This mechanism is instrumental in applications where accuracy is paramount, for instance, in medical or financial settings. Practical application and challenges. For AI practitioners, implementing Say Self can calibrate and assess LLM output confidence effectively, while trialing Aspire on QA datasets may reveal significant performance improvements. However, these frameworks aren't without challenges. Integration into existing systems poses computational overhead issues, and the risk of overfitting during fine-tuning can threaten the generalized applicability of models across diverse tasks. As AI systems become integral to decision-making processes, developing models that recognize their limitations fosters user trust. Models that can effectively self-assess reduce the probability of unchecked errors propagating through automated systems. Although full effectiveness across diverse tasks is pending further validation, initiatives like Say Self and Aspire demonstrate promising strides towards constructing AI systems viewed as accountable and trustworthy by their users. In conclusion, as AI continues to infiltrate critical aspects of society, embedding frameworks that facilitate self-evaluation and confidence calibration in LLMs could redefine trust dynamics between humans and machines, ultimately ensuring essential safety and reliability across varied domains. Ensuring the safe deployment of machine learning (ML) models in production is critical, given that around 85% of models fail to reach production successfully. This statistic underscores the challenges that organizations face, highlighting the need for robust deployment strategies to mitigate risks of degraded performance, which could significantly disrupt user experience. The article outlines 4 pivotal strategies designed to mitigate these deployment risks while maintaining a seamless user experience. 1. A/B testing. This strategy involves deploying 2 variants of a model simultaneously to compare their performance side by side. It allows businesses to collect data on which model performs better in real-world scenarios, enabling data-driven decisions for full deployment. Best practices dictate using statistical methods to determine the performance significance, often requiring a traffic split where each variant receives enough exposure for accurate comparison. 2. Canary testing. This involves gradually rolling out a new model to a small segment of users initially. This control group helps identify potential issues in a real-world environment without impacting the entirety of the user base. The approach minimizes risk by slowly increasing user exposure as confidence in the model's performance grows. This method becomes particularly crucial in sensitive industries where operational continuity is paramount. Interleave testing. Traffic is rotated between different models to assess performance in a dynamic environment. This allows organizations to observe how models perform under varied load and user interactions, offering insights into scalability and robustness. 4. Shadow testing. In this scenario, the new model runs in parallel with the existing system but without affecting the actual user output. This allows for performance analysis and debugging in a risk-free environment. It is invaluable for complex systems where understanding model behavior before full deployment is crucial for operational integrity. Implementing these strategies requires a robust infrastructure equipped with advanced monitoring tools and real-time feedback systems. Such tools are essential for tracking key performance metrics and identifying potential issues as they arise during testing phases. By providing early detection and remediation capabilities, these systems can prevent minor issues from escalating into major disruptions. Adopting controlled deployment methods can potentially reduce service disruptions by up to 70%, based on speculative industry reports. However, it's essential to acknowledge the trade-offs, such as the increased initial costs and the need for customized strategies based on application types and industry demands. Not all strategies will fit all applications, emphasizing the need for tailored deployment approaches. Organizations are encouraged to explore platforms like AWS that offer tools for implementing A/B and canary testing, which streamline the integration into existing ML operations. Continuous monitoring frameworks further ensure that model performance aligns with expectations post-deployment, ultimately fostering user trust and improving operational efficiency. To see these practices in action, consider reviewing the comprehensive guide on ML deployment strategies provided by MarkTech Post. Such resources offer valuable insights into how organizations can adapt and customize these strategies to meet specific needs, ensuring stability and reliability in their ML deployments. In today's landscape, ensuring AI reliability is a non-negotiable. Whether deploying models or governing AI agents, robust frameworks and strategies are imperative. Keep learning, keep adapting, and above all, ensure your AI systems earn the trust they require to truly transform.